Welcome. In this video, I'm going to demonstrate some of the modeling capabilities of Flexgen, which is the front-end modeler to our front-end element programs. So to do that, we're going to begin by clicking on the Analytical Methods Manager here. It brings up the program. And we will be going into a modeling session. So we'll hit Continue. So now we'll hit New and Flexgen. But before I do that, I want to show you what the final product is going to be. So we'll do a File, Load, Model, and come down to Disks on Shaft. We'll double click on that, and this is the model that we will be creating with our macro. So that's the final. It's 3 disks on a hollow shaft here. And we cut out a section there. It's actually continuous here, and they have tapered thickness from the outer diameter to the inner diameter here. The thickness is tapered, so you'll see how we go ahead and create that model. So right now we'll get out of that again, and we'll go back into New, and now we do a File, Macro, Run, and we're going to do it in the pause mode so that we can discuss what's going on. And here we come, and we'll double click on disks.mac. So the z-axis is going to be the axis of the shaft that it's on. So we'll be building a cross section of a disk first, and we're going to do a little rotating of the axis system here. And I know you can hardly see it, but that now says Z there and X in the other direction here. So we're going to input a node at a diameter or a distance of 3. Y is 0 and X is going to be 1. So there's that. We do one at 0 and we do one at -1. So the thickness on the inner diameter is 2 inches. And now we go to the outer diameter, which is going to be 12 inches out. And it'll be tapered, and it's only going to be ½ an inch thick out there. So we're done doing that. Now we want to do copy between pairs, and we'll identify the pairs that we're going to copy between, and we're going to insert 9 nodes in between there, 9 sets of nodes, and we're going to go equidistant there. They'll be evenly spaced. We'll hit that and say yes, we want to create 27 nodes. Now so that forms what the cross section of one of the disks will be. So now we want to copy those and start to rotate about the z-axis here. So we're going to do iteration 1 to begin with, and we'll do rotation RZ of 20 degrees. And yes, you can't see them very well, but we'll change the view direction here. And there they are. So we started out with this one, and we just created that one. Now we're going to insert a solid element. All of the elements in this model are solid. Element property 1 not found, we'll insert that. Material property, we need to create that. We're going to go with standard material 101, which is a glass aluminum ceramic. And a little bit more information. And we have to put all the elements in a group, so we'll create an element group called disk. And now we start. We could either select the nodes by clicking on them with a little trap box here, or you can just pound in the node numbers. So for the purposes of the demonstration here, I just put in the node numbers, and that creates the first element, and then again the second element, and now a third element. Now we're going to copy element 3 there and do that 7 times, and that'll generate elements down in this direction here, and the node increments there are -1. So yes, I want to create that. And I'm going to just copy those now and step up, and that creates those. So I want to finish off now by creating those two elements down there. And I change my view direction, something I can see, and I'm going to insert those elements again. And there's that one, and there's that one there. So now I have a wedge shape section of the disk. I'm going to change the view direction here, and I'm going to copy combine. So that's a command that will copy both elements and nodes combined. And I'm going to do that with one element 1 through 20. That's all that we had. And we'll do that 20 times around the perimeter. And we create 1,320 elements and 400 nodes. Yes, I want to do that. And now we'll zoom all, and there's our disk. So now I want to delete all the coincident nodes. So because I did a copy command, there's a lot of two nodes occupying the same location, and I want to get rid of all those. So I do a delete coincident, and I select all the nodes and the distance between them, and then I'm going to be deleting 792 nodes, and that did that. So now I'm going to start building the shaft and inserting some nodes in this area down here to begin with. There's the first one, the second one, the third one. Again, I'm building a cross section of the shaft. And I'm zooming in a little bit here, and I went a little bit too far there. I'll back up, zoom out, and now I want to copy those 3 nodes and do it 6 times going in the Z direction with an increment of 1 inch, and I'll create 18 nodes. So I'm going to do the same approach as I did on the disks there. I'm going to copy those and make a little tiny wedge there of the shaft. And now I'm going to set the element color to light red. I'm going to be inserting elements, and I want them distinguished from the disk. So now I want to turn off, I will here, I'm going to create another group, call it the shaft group, and now I'm going to create my first shaft element there, and there's 2 of them. And I'm going to generate, copy those a number of times and zoom all, and there we have our little section of the shaft. I'm going to turn off all of those unused nodes there, and I'm going to copy those, do that 20 times and around, and there we have our shaft section. So we'll zoom all on that and delete those coincident nodes, and that's 500 nodes there. So there we have turned on the other element group, and there's our first disk in that section of the shaft. So I'm going to move it, do a view mode hidden, and that's what that looks like. And now I'm going to do a copy combined for these and make 2 more of these, and creating a couple thousand elements and nodes. And there's the zoom all, and that's it. Now I want to insert a load, and I'm going to do a rotational velocity about the z-axis of 1,000 radians per second. So I'm doing that down here, and I will do that set load labels on, and you can see a little square. This is a load indication there. And we're going to translate this whole thing a little bit here. And we'll change the view direction and repaint it. And there's our model. Now we're going to cut a little wedge out of this just to show you the capability here. I'll look at it this way, and I'll do some selection, and I'll select those elements there to be put in a different group. Call that group 3, and that's just the cutaway group. And we'll set that group off and go back and zoom all with everything on, and there it is with the wedge cut out of it. And now we're selecting one of the preset windowing options here and titling this. This is discs on the shaft. We'll go to window 2, title that end view, go to window 3, title that side view, and window 4, and we're just going to show the shaft on this one like that, and title that shaft only. And that is the end of the macro. So we can do whatever we want here. We can come in and say modify window resize, and come up here and resize it to whatever we want. Look at it in different ways here. Okay, so that gives you some idea, pretty good idea about the modeling capabilities here of Flexgen. So we will conclude that and get out of Flexgen and then exit out of the session. So thank you very much.